safety factor 嗰個 concept 嘅，即係將個 loading 同個 material 咧就分開個 factor of safety， 咁啊 make sense 啲嘅，因為你個 loading 可能有某啲 uncertainty， 咁啊個 factor of safety 唔同啦，咁啊你個 material， 例如石屎或者泥，個 factor of safety 有唔同啦，咁啊所以分開啦嚇，所以 partial safety factor。咁我哋而家嘅做法就係將啲全部 combine 埋一個 safety factor， 即係 load 同個 material 啊，或者其他嘢 combine 埋，咁就喺個邏輯上又冇咁 convincing 啦，好明顯嚇。咁但係似乎咧就舊有嘅方法相對好似係保險啲啊，即係 on the safe side 或者conservative 嗰啲。似乎啊，我都係 exactly 啊，冇做過 research 啊，唔知啦。因為我見到出邊啲 design 兩樣都有，就算係比較新嗰啲都兩樣都有。好，咁啊，跟住咧就係同一條題目，不過咧就用咗嗰個 partial safety factor。咁個 example 就用Eurocode 嘅，因為嗰本即係參考本書啦，阿 Cray 嗰本書嚟嘅，咁所以都唔會改，即係都係其實你用翻 Hong Kong Code 即係改翻個 factor safety 嘅做。 OK， 好，乜書啊就冇瞄到啦，有陣時唔知撳咗咩掣。OK， partial safety factor。咁比較都係咁做啫，即係其實類似 is very similar to your structural design. So you have a different load factor for a loading. For example, you have a different factor for surcharge. The surcharge is loading. And then you have a different factor of safety for the material. For example, if you have a cohesion equal to 10, so if you apply a partial safety factor to it, then the cohesion will become 10 divided by 1.25. So it's very straightforward. So for example, if you have a surcharge of 10, and then after applying the load factor, it becomes, if the load factor is 1.3, so then it will be 1.3 times 10, so it's 13. So this is the idea. So you have a different factors for the material and different factors for the loading. But then there's one thing that is complicated, is the friction angle. So if the friction angle is 36, so it is not divided by 1.25, not like that. So it should be tangent 36 divided by 1.25, and then obtained the revised friction angle. So this makes the calculation a little bit complicated. 即係其實好容易理解啫，因為你哋 structure 咧都係咁做啦嚇，都係 material 還 material，load factor 還 load factor 都係一樣嘅啫嘛。唯一比較 complicated 咧就係呢個 friction angle 啊 ，friction angle。即係慣咗friction angle 36，咁除翻1.25，咁係咪咁咧？就唔係嘅。佢要你 tangent 咗個，即係因為嗰個 shear strength 咧，如果 if you look at the shear strength is actually equals to cohesion plus the friction, and then the factor of safety should apply to the whole equation. So it should be C divided by F, and then tangent phi divided by F. Okay, so this is the, so you have to use this to adjust the friction angle. And after the friction angle is adjusted, then you put it back into this Ka, Kp. This is the things that make it a little bit complicated. Otherwise, it is quite straightforward. 即係除咗呢個少少要 handle 之外，其他就都好容易理解嘅。咁啊，長遠都係用呢啲 Euro code 㗎啦，我估嚇，因為呢個嗰個 design philosophy 先啱，即係比較接近啊嘛。好，咁啊 make sure 啊，冇瞄到先，係啦，冇瞄啊。Okay, so this is, as I said, is if we use the global factor of safety, so first of all we have to recalculate this Ka, because last time our Ka is based on friction angle equals to 36. But because of the partial safety factor, the new friction angle then will become 30. The friction angle has to be calculated this way. So you have to calculate the friction angle like this. So it's the whole thing divided by the factor of safety and then convert it back to friction. So in this case, the design value of the friction angle then will become 30. So we have to use this 30 to calculate the new Ka. So if there's a Kp, so we also need to use that to calculate the new Kp. So this is the idea. Okay, so like before, we use 0.26, so global, but this time we use the 0.33. So this point will become 3.3, and this point will, because the Ka has been changed, so this pressure diagram has been changed. So to simplify it, we just replace this point with 3.3 and this point with 33.6。即係比較簡單啲，就係改咗個，你可以從頭嚟計過得嘅。But just to simplify it, I just actually the book just very quickly just change this value into 3.3 and this value into 33.6. And the rest is basically similar. Okay? So again, this is 記住呢個 delta x 咁呢個都啱嘅，啱嘅。咁不過咧，用 delta sigma 嘅時候咧，就呢個要加上呢個就先至係呢個嚇。This plus this 都係因為呢個 delta 啊嘛，呢個真係個 stress， 所以呢個加呢個先係呢個。咁啊，如此類推嘅。咁啊，嗰陣時唔知點解中意用呢個 percent。So I basically this, if you plot it to a graph, then this becomes 3.3, this becomes 33.6. So very simply, but then 即係唔想改咁多嘢，因為我都係跟翻嗰本書，咁啊改咗呢個啦。咁啊記住喎，呢個要乘翻1.3啊 ，because this has to multiply by 1.3. This is the load factor. So that's all that has been changed. Otherwise, other things has not been changed. So everything is the same. So 3.3 times, and then we give you this. Of course, the moment arm is the same. All the concrete is the same. Moment arm of the concrete is the same. So everything is the same except the horizontal force and also the overturning moment. And the resisting moment is the same. 咁我可能以為好咗係咪啊？可能sorry 以為差咗係咪 ？Resisting moment 就 same， 但係個 overturning moment 大咗喎，因為有個 load factor 啊嘛。嗱，記住咧，因為呢度我哋已經有 apply 咗個 factor of safety， 呢度有 apply 咗個 factor of safety， 所以咧我哋 check 嘅時候仲需唔需要再有 factor of safety 啊 ？Overturning 仲需唔需要2啊？唔需要咯喎，記住呢度喎，好多同學咧就呢度咧就有一定要嘅大過2喎，咁咪又即係 double 咗個 factor of safety 係嘛？唔需要啦，係嘛 ？Okay, so the rest is the same. So overturning moment, check resisting, over, make sure it's greater than 1, then it's okay. The we also need to check the eccentricity. Again, the net moment divided by the vertical slope is 0.88. And in this case, the eccentricity is greater than B over 6. So in this case, this is so good. And also apply this to check the maximum pressure. And in this case, a negative is also fine. 即係 negative 都有 negative 嘅做法嘅嚇，不過就冇咁好咯嚇。And also we also need to check sliding 啦。嗱咁 sliding 咧呢個 angle 就唔係27喎，記住啊。Because the friction angle has been changed, so because before we know that the friction angle is actually equal to 0.75 of the friction angle. If you still remember, if you go back to the questions, okay. If we go back to the questions, the friction angle of the sliding is actually 0.75 of the friction angle. And because the friction angle has been adjusted to be 30, so in this case, the friction angle again will be adjusted. 即係由36變咗做30喎，咁啊跟翻個比例啦，跟翻個比例adjust 翻佢咯。That's why the friction angle of the soil then will become 22.5. So after doing this, then the factor of safety against sliding is 0.83. Less than 1 is not okay lah. So this is how the partial safety factor can be used. And the idea is the same, but the procedure is complicated by the fact that the friction angle will be adjusted because of this factor of safety. And this is directly from the book, but the result is the same. 都一樣啦，個 sliding limit not satisfied, eccentricity not satisfied, sliding 又 not satisfied 啦嚇。咁呢個就嗰本書都係咁做啦嚇。So this is the we actually have a tutorial tutorial 2 and 3. Tutorial 2 is an example on a retaining wall using global safety factor, and tutorial 3 is using the partial safety factor. Okay, so we recap the basic concept. So basic concept check sliding 啦 ，overturning 啦 ，bearing capacity 啦。咁呢個係咩？記唔記得 ？Loss of overall 係咩意思啊？loss 有機會佢都係 like a overall slope failure. So in this case, we won't look into this, but however, remember when you are doing design, after you graduate, then make sure that you should include this slope check or slope stability check 嘅。因為我哋好多就幾個唔同例如structural design 啦，即係 RC 嗰啲 design 我哋冇啦，因為我哋都唔係計 structure， 但係記住咧出嚟做嘢咁啊要計翻 structural design 咯嚇。咁我哋淨係check sliding 啦，咁overturning 啦 ，bearing capacity 啊揾 maximum 啦 ，minimum 啦，咁同埋嗰個 eccentricity 啊。So the common types of loadings is actually weight 啦、水啦。咁你發覺咧就有個招街都有個 factor of safety for 呢啲嘅，咁我哋一陣間睇下。咁啊個 loading is actually from the water 啦、earth 啦、surcharge 啦、size 啦 etc。咁啊，唔好即係佢話，即係唔好即係信，即係都要 apply 下啲 judgment 啦。咁就如果係 partial safety factor 咧，就係記住呢個招界係 second edition 啊 ，second edition。我哋有兩個 edition， 我記住一個 global safety factor， 一個就 partial safety， 呢個係 global 啦。OK， 咁咧就其實你發覺大部分都係一啦，都 make sense 啦。咁 surcharge 就1.5啦。咁我哋頭先嗰個 Europe code 咧就係1.3嚟嘅嚇。咁你記住喎，我哋即係好多時咧 retaining wall surcharge， 我哋頭先係10，係咪？係咪啊？有個10。咁你記住咧，呢個 retaining wall sorry 呢個 surcharge 咧，淨係用嚟計起一個叫做 favorable 應該話 unfavorable 就計喎 unfavorable。如果係 favorable 咧就唔計喎 set 條線咩意思啊？咩叫 unfavorable 啊 ？unfavorable means 咧就係唔好啦，係咪害佢嘅？即係如果佢係 overturning unfavorable， 咁即係計唔計啊？咁即係計啊 ，yes， 係咪？好啦，咁我哋去到計呢個overturning， 咁呢個咁嘅 surcharge 會唔會加個重量喺度啊？幫佢啊？係咪幫佢啊？幫佢係 favorable 啦 ，unfavorable 啊？如果幫佢就係 favorable， favorable 計唔計啊？你要乘0咯，即係個 concept 就係咁咯，係嘛？咁啊要自己 apply 啲 judgment 啊嚇，得唔得？即係唔好係有計，唔係有計。OK， OK， so this is if this material 就係呢度係 material 啦，咁啊好即係好特別地咁計啦。咁呢個 material 嗰個 partial safety factor from Geotechnical 1嘅 second edition 啊， 好咁就基本上即係 differentiate global safety factor 同埋 partial safety factor 就係 based on 呢個 discussion。然之後跟住好似有 tutor 2 and tutor 3。跟住你哋嗰個功課咧，我就睇先嗱個功課 assignment 1。assignment 1，應該都睇到啦。Assignment 1, design retaining wall based on geotechnical profile. The dimension detail of the wall shall be cut as blah according to Geo 加2020喎嚇，記住呢個係即係咩 edition 啊？呢個應該係 second edition 喎，如果你上去睇嚇。嗱，因為最近嗰個 edition 喎。咁理論上應該呢個就係 partial safety factor 喎啊。咁你要諗一諗喎，各位同學啊。同埋記住咧，你啲 backfill material 唔一定係呢啲 material 啊。即係你預計 backfill material 就係通常都係啲 fill 啊咁樣啊。咁可能有啲資料要自己 assume 喎。Method check 嘅意思即係嗰個 eccentricity B over 6嗰個 concept。咁啊，點解係 method 咧？嘅意思即係我覺得唔係好靚。即係由呢度度起就 B over 6，呢度度起又係 B over 6，咁加埋係 B over 3，即係嗰個 concept 咯。你哋 short call 諗嗰個 concept，其實即係 B over 6嗰個 concept 咯。OK，pot 就係 pot 咯，跟住就海深就嗰啲水咯。Research check 應該就係呢個咯 ，sliding 啦 ，overflowing 啦。咁如果 check 埋最好，如果唔 check 就攞呢個嚟做，即係 make sure 個 bearing maximum 嗰個唔可以多過呢個啦。Question 2就係有個 slope 嘅，咁啊叫你用 method of cooler 去做，但係即係用翻呢個 design 完咧，就用呢個 check 去睇下得唔得。如果係佢有個 slope 係斜嘅，話30度都好斜。好，咁開始可以諗啦喎嚇。OK。
阿 Sir，
好，咁睇下同學有冇問題先。Sir，係咩事啊，林同學？ 我有冇 share 到啊？係 question 一 part 7 and 8 is op 係啊 optional 係，即係其實都 RC design 應該就唔包喺我哋呢度嘅，不過啲同學中意就做埋佢咯。咁佢話唔使做嗰啲就唔使做啦。Overall slope 咧，其實個意思就係嗰個 slope analysis 啦。咁理論上我哋係未教。Structural check RC design 其實就係咁，佢冇話做埋有幾多分喎，冇講喎。咁啊，即係當呢啲唔需要住啦，係。is actually always left length over 2咁啊唔知喎，但係即係其實我哋係因為 take moment about 最遠個點嘅。咁如果呢啲 case 咧，就通常就係因為我哋 eccentricity 係由中間度起㗎嘛，係嘛？即係你哋讀 short column 係嘛？咁所以就都係用呢個 concept 啦。係啊，大同學，即係佢講到明係 GeoGuide 2020啊。咁即係兩種方法都 OK 噶嘛，即係佢指明咁，你就梗係要跟佢嗰度啦。好，如果冇問題就睇埋跟住嗰個example 就係嗰個 Coulomb's method。咁跟住就有時間嘅話就睇埋個 tutorial 2同埋 tutorial 3。好，咁OK，so this is example 2。咁呢個去翻高步噶啦，應該高步 safety factor 啦。咁只不過係 introduce 點樣用個 Coulomb's theory。但係呢個唔係嗰個同個功課先同學，因為 assignment 1咧 ，it actually asks you to assignment 1咧 my wedge method。Please be reminded to find out the maximum lateral pressure with varies the angle of wedge load。即係真係要 trial 啲 wedge 出嚟喎嚇 ，trial 啲 wedge 出嚟。但係呢一個 example 咧就唔使 trial wedge 嘅，因為呢個 example 咧就冇水㗎嚇。咁佢就嗰條 formula 咧，即係呢條 formula 咧已經 trial 咗俾你㗎啦，所以咧呢度就唔使 trial 嘅。但係功課條就要 trial 㗎嘛，咁啊試下睇下點 trial 啦。Anyway，講咗呢個講咗呢個功課先啦，唔係講咗呢個 example 先。呢個 example 又唔使 trial 嘅，因為 actually just substitute into this formula. This formula actually has already give you the maximum or the required value. Okay, but if you still remember, the theory is that the angle acting on the this is the pressure or the force. This is the force, acting on this face is actually an angle friction. So after you calculate the pressure, you have to resolve this into a horizontal and vertical pressure. So actually, I think this is one of the key points. Okay, so the weight of concrete is given, the weight of soil is given, and the angle of friction is given. The friction between the soil 呢個唔係呢個係咩喎？應該係呢個。So this is the angle between the soil and the wall, and the angle of backfill of the slope, which is this one, and the angle between the back face of the wall, which is this one. So this one is 10 degrees. So it gives you alpha to be 100 degrees. So after that, then basically you just need to substitute into this equation alpha there.你睇翻嗰條 equation 嗰啲，after that, make sure that the h is actually the height, which is 6. K 計完出嚟就0.48unit weight. So this is the pressure, but don't forget this pressure is acting at this angle. 呢個26係嘛？呢個好似係10，咁26加10就加埋就係36。To the horizontal. So the force is acting at an angle 36 degrees to the horizontal. So if you resolve it to the horizontal direction, then you have to multiply this with cosine. So if you resolve this to the vertical direction, so you have to resolve this to sine. 即係記住呢度係主要係呢兩個位啫嚇。cosine 同 sine， 咁其他嘢冇乜特別啊，其他嘢照做。After you find the pressure, then you resolve it to the horizontal direction to give you the horizontal sliding force, and then if you know the moment arm, then you can also calculate the overturning moment. And then for the vertical load, 咁因為 vertical 佢都有少少嘅，咁加翻呢個少少上去。And this is the weight of the concrete, which is quite straightforward. And then this is the moment arm of the concrete. And then this will give you the resisting moment. So the rest is the same. So factor of safety is equal to resisting moment divided by the overturning moment. And the sliding is the horizontal force times the friction divided by the horizontal force, which is 係啦，唔錯。咁照搬翻啲數落去啫。1 by 1 level arm 又係嗰個 net。 係咯 ，net 嗰個數 ，net 嗰個 moment，除翻嗰個 vertical load 就係個 lever arm，咁啊 eccentricity 係嘛，咁啊 calculate 個 maximum pressure，咁啊你睇到呢個數同呢個數差唔多，即係話呢個數好接近零。但係都 OK 喎，啱啱 bigger than zero，都 OK。但係你功課嗰條可能唔係咁喎，可能真係要畫出嚟喎，真係要畫翻，因為功課嗰條有水嘅喎。Okay, so this is the idea of this question。其實主要即係等同學知道個要佢用 if you use that equation, then you have to resolve this into horizontal and vertical direction. So this is the okay. So as I said before, the drainage is very important, and usually we put drainage material behind the wall, and to make sure that to reduce the effect of water. 咁啊，後邊可能擺啲疏水石啦，最簡單，甚至乎擺啲嗰啲叫咩啊？可能包啲無沙石屎啊，或者包啲蛇皮通啊，出邊包啲疏水石屎啊，或者無沙石屎啊咁樣咯嚇，即係咁佢成個結構啊疏水。咁你會發覺咧 first cause by three case 喎，咁我哋係啦，呢度有個 case， 呢個 case 就係冇 drainage 啦，冇 drainage 咧，你要 design 個水咧，可能真係個 maximum 水喎。而呢個咧好唔好咧？呢個 vertical drainage U 等於0喎 ，very good，right？ But is this the best solution？ 如果你仲記得咧，我哋之前咧 ，if you still remember， maybe there's actually okay, so I'm showing you the chapter 2. This is actually from chapter 2. This is a video showing the retaining wall is failing. And you can actually see that there's a slip surface here. Right? 唔係我作上去嘅喎，我拆咗佢俾你自己睇。你真係有條 slip surface fell along this plane. Okay? So if you have pore water pressure U equals 0 here, if I put the drainage here, it's very good. So the pore water pressure here is 0. But what about here? Because water is flowing in. So this along here, because you put a drainage layer there, so the pore water pressure is 0. This is good. But what about along this line? We still have water pressure actually acting through it. So even if we have a vertical pressure, vertical drainage, we still experience some sort of pore water pressure along the slip surface. So the vertical drainage is actually not the best solution. That's the key conclusion. So what should we do? So if we want this pore pressure to be 0, so we can install what we call a inclined drain. So if you have an inclined drain, so this is 0, so then the pore water pressure will be 0. So that's why this is called a preferred drainage scheme. So we have a sloping drainage. But of course, this is quite expensive. 即係會貴啲啦嚇，又要 cut 個 face， 又 cut 多咗又貴啲啦，又要 backfill 翻，又要 compact 翻，要啲人工去 compact 佢，貴啲啦。So this is the idea. So that's why even though if we have a vertical drainage, we still assume some water pressure. 咁喺個 industry 咧，通常咧，就算你有 vertical drain 都 assume 1/3水。如果你想完全冇水咧，就要做呢啲 incline。咁呢個 incline 要斜幾多啊？記唔記得啊？啲同學有冇人有啲 suggestion 要斜？因為你唔 specify 個斜度啊，梗係盡量，梗係越斜就越貴啦，係咪啊？因為你要掘多啲泥，又要換翻多啲泥，咁要斜幾多先最好咧？咁又係我哋之前學過噶啦，有個所謂叫 magic number。呢個我哋成日都有個 magic number， 45加3/2，或者45減3/2，睇下你由邊度度起啦。呢個 magic number 呢啲啦，咁我哋咧就即係因為個 slip surface 就係45加3/2嘅 slip surface。咁你要低過佢先避到嗰個係啦。Okay. So this is the idea of the, and it's very quite important. Okay, so we recap what we need to do in the design. We need to do a very good site investigation, and we need to select the parameters. So we have to in a site investigation, we have to drill holes to collect samples, and then we also need to obtain the design geotechnical parameters, design assumptions, whether there's surcharge. For example, we have to assume the surcharge, etc., etc. And then we have to decide the layout plan. Of course, in the mill design, we need to do the structural design, the drainage design. So this is the idea. So this is where you can find the what's the values for the surcharge. If you want to make reference, you can make reference to this table. This is doing a site investigation, drill holes, and then collect data, and then determine the factor of safety, whether you use the global factor of safety or the partial factor partial factor of safety, etc., etc. And of course, yes, but this is a Europe code 喎，但係個 concept 都係咁用啦嚇 concept。咁啊，記住 unfavorable、favorable 嗰啲 concept。咁啊，呢個係 Europe code 啦，呢個 Hong Kong code 啦。KD6 好。Okay, so係咪有個 message？ So we need to use partial。係啊，華生啊，我答咗你啦。Okay, see if there's any questions. Download. OK， 哎呀，我連嗰啲都自己講。Download to answer of people to the tutorial 1 tutorial 2.好，咁啊睇睇個 tutorial 2啦，好唔好？同學有冇特別騷擾我嘅？So we'll look at the perhaps look at the tutorial 2 first. Tutorial 2 is actually using the tutorial 2 and tutorial 3 are the same, except tutorial 2 will be using the global safety factor, and tutorial 3 will be using the partial safety factor. So this is the questions. So in here, then, so the levels for each of this is given, and bear in mind that actually for when calculating the soil, because as I said before, when you are constructing a retaining wall, actually you need to excavate this away, and then you put your retaining wall there. I don't know what's the depth of the retaining wall. And then you backfill it. Sometimes you have to excavate， 因為你驚嗰啲泥冧落嚟，你要打斜 excavate 走晒呢啲。So this material will actually becomes the backfilling material, which is actually given here instead of the native material. Okay, so in this so in this example, the shape. So this is so in this example, this is the shape of the retaining wall and the density of concrete, and you are asked to use the global factor of safety for tutorial 2, and this is the factor of safety you need to achieve. If you in the Excel file, there's actually 2 sheets there. The first sheet is only cover the checking of the sliding, overturning, eccentricity, and to find the maximum bearing capacity, etc. And the second sheet actually also include the foundation design. So you actually just need to look at sheet number 1 in the Excel file. And we should go to the tutorial 2. Okay. So this is tutorial 2. So what's the height? So this is design retaining wall. So I asked to design retaining wall up to level D, I think. No, up to level D, or up to, sorry, up to I think up to level B. So you're asked to design retaining wall up to level B. Okay. You see that in this case, there's actually a shear key. So in dealing with the shear key, we actually, when checking the sliding, we actually check the sliding up to the bottom of the shear key to allow for the maximum sliding force. So when checking for sliding, so we actually, when we calculate the pressure, we actually extend it down to the bottom of the shear key. Whereas for checking for overturning, so we actually check it because we take moment about this point. So the pressure used to calculate that will extend up to this point. So there's a little bit difference between checking the overturning. So we plot this pressure diagram up to this point. Whereas when we are checking sliding, we plot the pressure diagram up to this point. So you will see actually there's a little bit difference when checking the sliding. This is quite conservative actually. You can, this is actually quite conservative. You can use this. So the first thing you need to do again is to calculate the Ka and Kp because we will be using the passive pressure in this case up to the base of the slab. And then the
EA project relating
，and then we will use the Ka of the
多
backfill
層次咁啊，有咩層啊？
for this soil, which is this one here. And for the passive pressure, we will use this soil. Okay, and there's a little bit of cohesion. Okay. So when calculating the pressure diagram, we actually use the backfill material. We use the backfill material instead of the native material. So we use the backfill material. Again, there's no cohesion. And we calculate, because we calculate based on checking the sliding and also on the overturning. So we actually calculate up to the top of the slab, bottom of the slab and bottom of the key. So we actually calculate the pressure up to this point and also up to this point. So So for checking sliding, so we calculate the pressure up to the bottom of the slab. So this is up to the bottom of the slab. 即係3，即係呢度度起咯。呢度就3米，係咯，呢度係3.5米，即係佢畫出嚟係咁嘅，但係呢度3米，3.5米係咯。So this is 3 meter, and then 3.5 meter. 我應該delete咗呢個。 呢個唔使啦，呢個嚇。Okay, so this is the moment arm, and then this is the overturning moment about this point. And then on the passive side, it's basically the same. This is 1.5 and 1 meter. Okay. And this is the resisting moment. And there's no factor of safety applied here, so you have to make the assumptions. Okay, so this is for checking the overturning. But for checking for sliding, remember that we extend this to the bottom. So that's why it takes 4 meters. Okay, so for checking overturning, then this is the weight of the concrete, and this is the resisting moment from the concrete and the soil. 哇，嗰個 check overturning 就好容易啦，1709。咁啊，呢個就係個 passive pressure，呢個就係石屎兩個加埋，除翻呢個 overturning moment，overturning moment 就應該上邊呢個啦，32係啦，32呢個OK， 咁就跟住就係 check sliding 啦。sliding 就係石屎個 vertical weight 乘嗰個 friction angle 啦。咁啊，記住喎，我哋而家有個 shear key 喎，shear key 有咩用啊？咁佢係找住啲泥喎，咁啊找住啲泥咧，佢就可以用翻泥嗰個 friction angle。咁我哋冇 cohesion 啊，冇嗰啲，咁就計咗出嚟大咗一點，咁啊 OK 啦。咁啊 eccentricity is the same, so we take the net moment divided by the vertical load to give you the eccentricity。咁啊，好似計到個負數嘅，咁啊記住咧就唔好理佢正負啊嚇，用個 absolute value，因為你 moment 就可以咁咬，可以調翻轉頭咬都得噶嘛。咁個 maximum 可以喺呢度或者喺呢邊都得噶啦。咁啊冇，即係我哋純粹係計 maximum 唔 minimum 啫嚇。咁啊 checking the maximum value pressure is 98.5, so it's less than 150, so it's okay. So this is basically checking the retaining wall using the global safety factor. And for the tutorial 3, actually this is on using the partial safety factor, but the basic concept is the same. Again, when checking the sliding, we use the pressure diagram up to the base of the shear key. And for checking the overturning, we use the pressure diagram up to the base of the slab. So actually, we have 2 pressure diagrams. So when we are checking overturning, we take moment about this point. but then for sliding, we actually extend the pressure. So in this case, we have to adjust the friction angle. So here we are actually using this actually. So adjust the cohesion. 有冇 cohesion 呢個有啊？ So the new Ka should be calculated based on this, and the new Kp should be calculated based on this. So Ka should be 0.368. 0.368 Ka. And Kp should be 2.716. Yeah, 2.716. And because we don't have surcharge, or the most surcharge, so we don't have to worry about the safety factor for the surcharge. 咁啊 surcharge 冇喎，我哋嚇咁啊慳翻。咁啊又係一樣啦，就個深度唔同咗嘅喎，今次啊。So again, if we are checking for the overturning, so we use this pressure tracker up to the base. 咁啊呢度就係同頭先嗰個唔同嘅個 size。And from there, then you can calculate the moment. And this is from the passive pressure. Okay, so this step is the resisting moment. Sorry, this is the overturning moment. This is the resisting moment. So if you are checking the sliding, 咁啊 sliding 因為佢有個 shear key 嘅，咁你要拉到落嚟呢度啊。咁啊計埋呢個咁啊保守啲啦，安全啲啦咁樣啊。So this is the resisting moment. So basically the same, but in checking, make sure that actually the factor of safety, if it's greater than 1, then it's okay. 因為之前我哋 apply 咗啲 factor of safety 喎，咁啊 it's the same for sliding greater than 1。咁呢個 sliding 咧就記住呢個咧就係又係用嗰個 factor 咗嘅喎，記住啊呢個 factor。咁啊其他嘢都係咁計啦。So these are the two examples that explain the use of global safety factor and also the partial safety factor. Okay. People.好，咁我哋睇下同學。問題啦，download。 星期六個 test 可唔可以轉翻？唔係我決定喎，因為聽到啊，唔係我決定啊個 test。日頭嘅老師係
阿 Sir 啊，阿 Sir，係阿 Sir，喂阿 Sir，聽唔聽到啊阿 Sir？